Good day everyone, welcome once again to our session. So today we are going to discuss about integration by partial fractions. Alright, so integration by partial fractions, we have to recall what we have learned. I think this is from algebra. So we have here method of partial fractions. So we have here the form that is f of x divided by g sub x. Okay, so that is the method of partial fraction proper. So in this integration, we have here the rule that we're going to follow. So number one, if we let x minus r be a linear factor of g sub x, okay, so suppose that x minus r raised to power m is the highest power of x minus r that divides g sub x, then to this factor we need to assign the sum of m partial fractions that is in this form. We have e1 divided by x minus r plus e2 or a sub 2, a sub 1 divided by x minus r plus a sub 2 divided by x minus r raised to power 2, plus and so on and so forth, plus until whatever is the value of n here. So a sub m divided by x minus r raised to power m. So you need to do this for its distinct linear factor of g sub x. Okay, so that's number one. Number two, let x squared plus px plus q be a quadratic factor of g sub x, and suppose that x squared plus px plus q to the n is the highest power of this factor that divides g sub x, then to this factor assign the sum of the n partial fractions, so that is in this form. Okay, and do this for its distinct quadratic factor of g sub x that cannot be factored into linear factors with real coefficients. And then after that, we need to set the original fractions f of x divided by g sub x equal to the sum of all these partial fractions, and clear the resulting equations of fractions and arrange the term in decreasing power of x. Then lastly, we need to equate the coefficients of the corresponding powers of x and solve the resulting equation for the undetermined coefficients. Okay, so that's the rule class that we need to follow when we solve integrals that can be solved only using integration by partial fractions. So if this is not clear with you, then perhaps in our example you'll be able to understand. Okay, so let us summarize this concept into this example. So integration by partial fractions. So we have here the first example. So we're given here the integral of 1 divided by x squared minus 4 dx. So using that rule that I've shown you a while ago, okay, so we need to factor and decompose into partial fractions. So it means, class, that when you do or follow the rule that I've shown you a while ago, so we can rewrite this as the integral of 1 divided by, so factoring the denominator, so we have x plus 2 times x minus 2, then times dx. Okay, so we had factor the denominator. After that, we need to decompose into partial fractions as mentioned earlier in that rule. So it means we have to rewrite this as the integral of a divided by the first factor of the denominator, which is x plus 2, then plus b divided by the second factor of the denominator, which is x minus 2, and then everything is multiplied by dx. Okay, so what's next? So the next thing to do is to we have to solve a and b. Okay, so how to solve a and b? We need to equate. No, we have here the numerator. A and b here is also, or are also, the denominators. So we need to do it this way, class. 1 is equal to 1 over this x plus 2 times x minus 2 equals, so find LCD at the right side. So LCD of this x plus 2, or before that, okay, let's rewrite it in this manner. So a divided by x plus 2, then plus b divided by x minus 2. Then at the right side, find the LCD. So we have x plus 2, x minus 2. Okay, and then this denominator, or this LCD, divide by this. So what is left is x minus 2. X minus 2 multiplied by the numerator. So we have a times x minus 2, then plus, so this is plus, and then the LCD divided by this. So what is left is x plus 2. X plus 2 multiplied by b. So we have b times x plus 2. Okay, so this is our right side, and our left side is 1 over x plus 2 times x minus 2. So to solve for a and b, we need to equate the numerators. So equating the numerators, but before that, let me use another board here. Okay, so we have 1, so this one here, equal to, the numerator is, or the numerators are, the numerator is composed of a times x minus 2, then plus b times x plus 2. Okay, to solve for a, we need to set the value of x in such a way that these are the values of x that can make this denominator equal to 0. So this denominator equal to 0, which this one, x minus 2, to make this equal to 0, so that will happen only when x is equal to positive 2. So when x equal to positive 2, substituting it in this equation, so we have 1 equal to a times, so when this is positive 2, so 2 minus 2, then plus, so b times 2 plus 2. So this part here, the first term, so 2 plus 2 is 0, so a times 0, so the whole thing here, this becomes 0. Okay, so what is left now is 1 equal to b times 2 plus 2 is 4, no? 4 times b is 4b. So here we can solve b. So our b here, our b is equal to 1/4, no? So from this equation, we have b is equal to 1/4. So how to solve b equal to 1/4? We just divide both sides by 4 from this equation. Divide both sides by 4, so you get b equal to 1/4. Okay, so you might wondering why we set x equal to 0. So if you look at this one class, so the values of x should be the value that can make the denominator equal to 0. Okay, so in x equal to 2, so this becomes 0 multiplied by this 0, so everything becomes 0 on the denominator. So anything divided by 0, so that's undefined. Okay, so those are the values that we need to avoid, no, to avoid this result of undefined. Okay, and another value for x that can make this denominator equal to 0 is when x is equal to -2. Alright, so when x is equal to -2, so we have 1 equal to we have a times -2 minus 2, then plus b times -2 plus 2 so 1 equal to, this is minus 4a, and the whole thing here, since the second term, since -2 plus 2 is equal to 0, 0 times b is equal to 0, so the whole thing here is equal to 0. So from here, we can solve for our a. So our a here is equal to minus 1/4. Okay, so a is equal to minus 1/4. So we get a equal to minus 1/4 by dividing both sides of this equation here by -4. So we get a equal to minus 1/4. So after solving for a and b, then we can substitute this value to what we had done a while ago, no, from here. Okay, so from here, substituting our values of a and b from this expression, and then integrate each term. Alright, so I'll just rewrite now what we had a while ago. So we have okay, I'll rewrite it this part class just to save space. So we have the integral of a divided by x plus 2 then plus b divided by x minus 2. Okay, so we can put this inside the parenthesis, this one also, or you need not put this inside the parenthesis. So the integral of this multiplied by dx. Okay, substituting the value for a and b, so we have the integral of our a is minus 1/4, so minus 1/4 divided by x plus 2, then plus 1/4 divided by x minus 2, then the whole thing here is multiplied by dx. Then you can distribute the integral sign and also the dx, so you can integrate each term individually. So you have integral of minus 1/4 divided by x plus 2, dx, then plus the integral of 1/4 divided by x minus 2 times dx. Okay, you can put equal sign here. So equals using the division of fraction, the rules in dividing fractions, so we can rewrite this as minus 1/4. So integral of, this is dx over x plus 2, then plus, this is 1/4, integral of dx over x minus 2. Okay, then from our previous lesson, if you have if you can still remember from our previous lesson, if you have, say, integral of du over u, so this is equal to ln u plus c. Alright, so we have to make use of this integral formula, so to solve this integral here. Okay, so if we set our let u equal to x plus 2 for this term, so we get du, which is equal to dx. Right? Similarly, for this term here, if we let u equal to x minus 2, then we have our du is equal to dx. So they are in the form of du over u, right? Du over u. So we can use this formula. Integral of du over u is equal to ln u plus c. Okay? So therefore we can say that this is equal to minus 1/4 integral, this is in the form of du over u, so this is ln u, where u is x plus 2, then plus 1/4 ln, our u here is x minus 2, so x minus 2, then plus c. Okay, so that's our answer, but we can still express this in another form by using the law of the logarithms. So just recall that we have this expression class. Okay, so from our algebra, if you have this ln of m minus ln of n, so this is just equal to ln of m divided by n. So we have to make use of this equivalent. So therefore our final answer could be written as we can rewrite this as we have here common, which is, or before we apply this, we have to factor out common first. So we can rewrite this as ln by the way, the common factor here is equal to 1/4, so factoring out 1/4, but take note this is negative, so we can write this as factoring out 1/4, so 1/4, then we have ln, so 1/4, so write this first, the positive one, so ln of x minus 2. Okay, then minus, this is negative, okay, so this is negative, so this is minus ln of x plus 2, okay, plus c. And this time we can apply this logarithmic rule. So our final answer could be written as 1/4 ln of, so this is we can consider this as our m and this is our n. So therefore we can write this as ln of x minus 2 divided by x plus 2 then plus c. So this is our final answer. Okay, so this is our first example class for this integration by partial fraction. Alright, so thank you very much. See you again in our next video for our next example. Bye.